Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the volume of cones. Before we do, let's review exactly what a cone is. So a cone is a three-dimensional object with a circular base. So in this cone shown, here's our circular base that tapers to a point called a vertex that is directly above the center of the base. So in this cone shown, our vertex would be right here at the top. Cones have a unique property in that their volume is always 1/3 the volume of a cylinder with the same height and the same radius. So when we look at the formula for the volume of a cone, let's describe the formula in words and algebraically. So let's start with words. The volume of a cone is 1/3 the area of the base of the cone times its height. So our formula would look like this. Capital V equals 1/3 area of the base, capital B, times the height. Now, in a cone, because the base is a circle, the area of the base, or the big B, is pi r squared. Okay, so in example 1, it says we have a cone is shown below with a radius of 5 inches and a height of 11 inches. Find the volume of the cone. So in this problem, they're asking us for volume. So we want to use our volume formula for a cone, which is capital V. Volume is equal to 1/3 the area of the base, which is capital B, times the height, lowercase h. So let's replace the big B with the area of the base, which is pi r squared h. So now we're going to substitute in the two things we know, which is the radius and the height. So volume equals 1/3 pi parentheses squared parenthesis, and I will plug in 5 for the radius and 11 for the height. Now, you can use your calculator here. I'm going to be using my Desmos calculator to calculate this. So 1/3 times, let's see, oh, I typed that in wrong. Let's see, 1/3, side arrow, pi, parenthesis 5, parenthesis squared, parenthesis 11. So we're going to round this to the nearest tenth. So 287, oh, that would be 288, excuse me, 0.0 cubic inches. In example 2, it says find the volume of the cone shown below. Round to the nearest tenth. Now, in this problem, notice that they did not give us the radius. They gave us, excuse me, they gave us the diameter. So what I want to do is be sure to label the radius so that we don't accidentally use the diameter when we're using our formula. So the volume is equal, the volume of a cone is equal to 1/3 times the area of the base, big B, times its height, little h. So volume equals 1/3. The area of the base is pi r squared, and then lowercase h. Pause the video and try the rest of the problem on your own. All right, welcome back. Let's see how you did. So I did 1/3 pi, parenthesis squared, parenthesis, and I plugged in a 4 for my radius and a 9 for the height. Then I used, I'm going to use the calculations that I already have. I'm going to change this 5 to a 4, and I'm going to change this 11 to a 9. So 1/3 pi times 4 squared times 9. So they want us to round to the nearest tenth. So the volume is 150.8 cubic centimeters. All right, example 3. Find the volume in terms of pi for each of the following. So in problem A, we've been given a cone with a diameter of 18. So before I do anything else, I'm going to draw in just the radius and label that with a 9. And this cone has a height of 16 centimeters. Now, I'm asked to find the volume in terms of pi. We'll talk about what that means in just a second. So let's write down our formula. Capital V, volume equals 1/3 times the area of the base, big B, times the height. So volume equals 1/3. The area of the base is pi r squared times the height. So volume equals 1/3 pi, parenthesis, squared, parenthesis. So I'm going to plug in a 9 for the radius and a 16 for the height. Now, because I want to leave this in terms of pi, when I put this in my calculator, I'm only going to multiply the 1/3 times the 9 squared times the 16. Okay, here's what I mean by that. 1/3 times 9 squared times 16. And that gives me 432, and then we have our pi. So because I'm leaving my answer in terms of pi, what that means is you're not going to multiply 432 times pi to get a decimal answer. You're going to leave it like this as an exact answer. And then our units are cubic centimeters. All right, pause the video and try problem B on your own. All right, welcome back. Let's see how you did. So here we have volume equals 1/3 times the area of the base times the height. So volume equals 1/3. Area of the base would be pi r squared times the height. So volume equals 1/3 pi times something squared times something. For the radius, I'll plug in a 6. For the height, I'll plug in a 15. Then, because I'm leaving this in terms of pi, I'm going to multiply the 1/3 times the 6 squared times the 15. So when I do that, whoops, I can just edit this formula here. I can change that 9 to a 6, and I can change that 16 to a 15. So 1/3 times 6 squared times 15 gives me 180. So this would be 180 pi, and it is also measured in cubic centimeters. So check your answer with mine. All right, in example 4, it says find the height for each cone described. So notice in this problem, they did not say find the volume. It says find the height. So in problem A, they gave us the volume to be 108 pi cubic centimeters and the diameter of the base to be 12 centimeters. Now, if the diameter of the base is 12 centimeters, we know the radius is 6. So our volume formula is volume equals 1/3 times the area of the base times the height. So volume equals 1/3 pi r squared times the height. Now let's plug in what we know in this problem. We know the volume we were given was 108 pi. So 108 pi is equal to 1/3 pi times 6 squared times h. So we don't know h. All right. Now I'm going to simplify the right side. So let me just write down the left side, 108 pi. That doesn't change. But I want to simplify this a little bit by multiplying 1/3 times 6 squared. So here I'm going to go back and just delete this. So 1/3 times 6 squared would be 12. And then pi, we have a pi there, and an h. Now remember, we're trying to solve for the height. So that means I want to get the height by itself. So I'm going to divide both sides by 12 pi. So on this side, the 12 pi will cancel with the 12 pi and leave me h. Over here, I'm going to say 108 pi divided by 12 pi, and that gives me 9. So the height of our cone would be 9 centimeters. All right, pause the video and try problem B on your own. All right, welcome back. Let's see how you did. In this problem, it gave us the volume of the cone to be 54.45 pi, the diameter of the base to be 6.6 centimeters. So that means our radius would be 3.3 centimeters. Our volume formula is 1/3 times the area of the base times the height. So our volume is 1/3 pi r squared times the height. Now plug in what I know, 54.45 pi is equal to 1/3 times pi times 3.3 squared times h. Now, there's nothing I can do to simplify the left side, so I'll write it down, 54.45 pi. On the right side, I can simplify it a little bit by multiplying 1/3 times 3.3 squared. So let's try that. I can just edit this up here, change the 6 to 3.3. Okay. So 1/3 times 3.3 squared gives me 3.63 pi h. Now, because you're trying to find the height, we want to get the h by itself. So we'll divide both sides by 3.63 pi. Divide by 3.63 pi. So this would cancel, and this would cancel with this. So on this side, I'd be left with an h here. 54.45 pi divided by 3.63 pi gives me a height of 15 centimeters. And that concludes today's lesson, Volume of Cones.